Greetings everyone. The next unit is on applications of trigonometry, and we're going to start by talking about the law of sines and law of cosines, which are two things you should probably know already, but we're going to go a little bit more in depth. So first problem says solve the triangle given A, B, and C. Now when we see this, I'm just going to start by sketching a triangle. And capital letters are usually used to designate the angles of this triangle. Small letters are used to designate the lengths of the sides. So side A is always across from angle A, so that's 22 units. Side B is across from angle B. Side C is across from angle C. So first thing we should always start with is just a sketch of this triangle. Okay. Now, if you know any angles, we can use the law of sines. If we don't know any angles, like in this case, we need to use the law of cosines. The law of cosines looks like this. Any side squared equals the other two sides squared and added together, minus 2 times the other two sides, 2 times A times B times the cosine of angle C. Now, this angle C corresponds to this side C. So we could actually set up 3 different cases of the law of cosines. We start with A squared, we're going to end with the cosine of angle A. Okay, so I'm just going to use this form right here and plug in everything we know. We know that side C is 15, so I'm going to say 15 squared equals 22 squared plus 17 squared minus 2 times 22 times 17 times the cosine of angle C, which we don't know. Now notice we know everything in here except that angle, so I can simplify. I can grab my calculator here and simplify. I get 225 equals 484 plus 289 minus 2 times 22 times 17 is 748 times the cosine of angle C. Now here's the biggest error people make with these problems. The biggest error people make is that they add and subtract all this stuff together. We should not do that because that last number there, 748, is multiplied by the cosine of C. So we can put these two together. So we can say 225 equals, let's see here, 773 minus 748 times the cosine of angle C. Now at this point we need to subtract 773 and then divide by this number. We should not combine these two. Careful, do not do that. So if we do that, we get, let's see here, I believe we get negative 548 equals negative 748 times the cosine of angle C. And then if we divide both sides by negative 748, we get about 0.73 or so is about the cosine of angle C. Now if we take the inverse cosine of both sides, and before you do that, check the mode on your calculator to make sure your calculator is in degree mode, you get angle C is about 42.9 degrees or so. So I'm going to put that in this spot, 42.9 degrees. Okay, now that we've got that, we could continue to use the law of cosines to find the other two angles, or at this point we could use the law of sines. Law of sines is a little bit easier, so I'm going to switch over to the law of sines. I'm going to say the sine of that angle, 42.9 degrees, over the opposite side, which is 15, equals the sine of any other angle, so I'm going to say here the sine of angle B over the opposite side, which is 17. Now just a little tip for you in general. In general, either find the biggest angle first, which would be angle A, or find that biggest angle last. It's possible to make little mistakes if you find the biggest angle in the middle, because that biggest angle could be 85 degrees or 95 degrees, and the sine of both of those is the same. So either get the biggest angle first or last. Okay, I'm just choosing to get that biggest angle last. Okay, if I cross multiply here, I'll get sine of B equals some decimal answer. If I take the inverse sine of that, I get angle B is about 50.5 degrees. And I'm going to put that in this spot here. And then lastly, there is one angle missing, so if I subtract these two from 180, I get angle A, which is about 86.6 degrees. Okay, so when the directions say solve, it means find all the missing parts. We were given the three sides, now we found the three angles. Now let's extend that problem a little bit. So second example here says find the area of the triangle in the previous example. So that triangle looked like this. I'll just make a rough sketch of that triangle again. And sorry, not the greatest sketch here, but we've got our three sides, not drawn to scale by any means. Now we can find the area of a triangle a number of different ways, but if you're given the three sides, the easiest thing to do is to use Heron's formula. Heron's formula says first find S. S stands for the semi-perimeter. Kind of like if you have a semicircle, that's a half circle. Semi-perimeter is half of the perimeter. Once you know the semi-perimeter, we can plug it into this. We can take S times S minus A times S minus B times S minus C. Really an ingenious formula here. So if we plug in everything we know, we get 15 plus 17 plus 22 divided by 2. And I believe that value is 27. Then we can plug all those things into this formula. So we get the square root of 27 times 27 times minus one of those sides is 12, times 27 minus another side is 10, times 27 minus the third side is 5. And if you do that, you get that that area is about equal to 127.3 square units, whatever the units happen to be. Okay, now that formula, once you get it, pretty easy to use. Here's the guy that came up with it. His name is Heron, and a little bit about his background. Take a look when he lived. He lived in about the year 10 to 70. Now here's something kind of amazing. So all this stuff in here, he's also known as Hero. It's quite a nickname. Check this out. He was mainly known for his mechanical inventions, contributing from the theater to the military. And here's his invention. The first steam engine, I like this one, the first vending machine. So little bonus, go online and check out what the first vending machine gave out. Remember, this was about the year 50. So about 2,000 years ago, he invented a vending machine. Kind of strange that something like that would happen. All right, so a little bit about Heron. Let's go into another example. We need to solve triangle ABC here. So again, we're given some information. I'm going to start with a sketch. So I'm just going to make a rough sketch of triangle ABC down here. Okay, here, let me draw it this way. Remember, the angles are the capital letters. So that means angle A is about 20 degrees. Side A is 12, and side B is 31. Now notice we can use the law of sines here to find the missing angles, and use the fact those angles add to 180, and then use law of sines to find this missing side. Now, I'm sure you've seen this kind of problem before, and you have no trouble solving for these sides and angles. However, this is a special case here. So this special case, it's what's called the ambiguous case, meaning there's actually a couple different solutions for this. One solution looks like the sketch that I have here. Another solution looks like this. So same kind of triangle. We've got one side is 31. We've got angle A down here, which is 20 degrees. We've got angle C up here. But then instead of angling this side that's 12 units to the right, I'm going to angle it a little bit to the left here and say this is 12 units, and this is angle B. Now what's up with this? Well, notice what we're given here is angle side side. Angle side side. And back in your geometry days, you learned that angle side side is not a triangle congruence. In fact, I feel very funny even writing this on this page because it does not make a very nice word. So I'm going to get rid of that. But if we ever have that relationship where you're given angle side side, angle side side, we can't use it as a triangle congruence. We also have to be careful because sometimes with angle side side you get no solutions. Sometimes it's just one solution, and sometimes you get two possible solutions. So here's how you know. First of all, angle side side, if you ever see that, special case. Second of all, the angle you're given has to be acute for it to be a special case. If that's obtuse or 90 degrees, you're either going to get one solution or no solutions. And third thing you look for is that this opposite side must be less than the adjacent side. When I say adjacent, I mean next to the given angle. So if those three things occur, angle side side, acute angle is given, and opposite side smaller than adjacent side, you could possibly have two solutions here. You could have no solutions, but you could have two solutions. So let's just run through like we normally would. I'm going to solve this triangle right here using the law of sines. So if I do that, I can say the sine of 20 degrees over the opposite side, which is 12, equals the sine of angle B over the opposite side, which is 31. And if you cross multiply and solve, you'll get angle B is about 62.1 degrees. Which means that angle C, since it'll add to 180, is about 97.9 degrees. And then from there we can use the law of sine once more. I won't go through all the steps, but then you'll get side C is about 34.8 units. Now, that solution is perfect. That's one possible solution. However, we have another possible solution over here. Now, why do we have another possible solution? Well, see this angle B that was 62.1? If we were to draw this back this way, well, this side would still be 12. This angle here is the same thing. So this angle out here would be 62.1 degrees. Now, what we really want to know is this missing angle in here. However, we know that these two add to 180, so if we take 180 minus 62.1, we have another possibility for angle B. And that other possibility is about 117.9 degrees. Now, why does it work? Well, type this in your calculator, the sine of 117.9. Okay, decimal answer, right? Then type this one, the sine of 62.1. Guess what? Same answer. So that angle will work for both of these. Or excuse me, those two different angles will both work. Okay, so now that we have this other case, let's use that other angle to find the other missing angle C. Again, they all add to 180, so that missing angle C would be about 42.1 degrees. And then using the law of sines, you can find side C in this case, which would be about 23.5 units. So be careful with this. You could get two solutions if you ever have angle side side. You're given an acute angle, and the opposite side that you're given is less than the adjacent side that you're given. So when you see these three things happen, a red flag should go off in your mind. You could have two solutions. Okay, let's run through just two more problems. On your next test, guarantee you're going to have this problem. So put a star in your margin, write this down. You need to know the proof of the law of sines. Where does it come from? You used it in your geometry class, you used it in Algebra 2, but you got to know where it comes from. So let's talk about how we can get the proof of the law of sines. So to prove the law of sines, I'm just going to start by drawing in the height of this triangle. Now height, it's a right angle height. I'm going to put an H in here. Now the reason I do that is because, well, trigonometry works great for right triangles, not so great for these other triangles. But if I draw the height, I've really got two right triangles. So on the triangle on the left-hand side, I'm going to say that the sine of angle A is equal to, sine is opposite over hypotenuse, so it equals H over C. And if we solve that for H, we get C times the sine of A equals H. Okay, let's do the same with the triangle on the right-hand side. We can say the sine of angle C equals H over A. And if we solve that for H again, we get A times the sine of angle C equals H. Now notice, each of these are solved for H. So that means we can set those equal to each other. So we can say C times the sine of angle A equals A times the sine of angle C. Now, if we choose to divide both sides by AC, and that's fine, we can always divide both sides by the same value. Over here, we can simplify. Over here, we can simplify. And look what we're left with. We're left with the sine of any angle over the opposite side equals the sine of any other angle over the opposite side. There's the law of sines. There's where it comes from. All right, be sure you can do that for the next test. Now that one's not so bad, but the proof of the law of cosine's a little trickier. So let's see what we can do. So I'm going to start by, same thing, triangle ABC. And same thing, I'm going to draw this perpendicular height in here. And before I start, I'm just going to put a star in the margin because guaranteed this is a test question on your next test. Okay, now if this entire base is B units, I'm going to call what's over here on the right, I'm going to call this amount X, and this amount will be B minus X. Okay, and the reason I'm doing that is because I want to use the Pythagorean Theorem here. So on the left-hand side, I can say B minus X, quantity squared, plus H squared equals C squared. If we simplify that, this B minus X squared, I'm just going to write it out twice so I can multiply this together using the distributive property. So if I do that, I'll get B squared minus 2bx plus X squared, and then I'll bring down plus H squared equals C squared. Okay. All right. Now I'm going to do the same thing on the right-hand side. Let's use the Pythagorean Theorem here. On that side, we get X squared plus H squared equals A squared. Now I want you to notice something. See this X squared plus H squared? See this X squared plus H squared? Same quantities, right? They're all equal to A squared. So I can do a substitution over here. So I'm going to write this as B squared minus 2bx plus A squared equals C squared. Okay, so we're kind of stuck at this point, but we have to look at another angle over it. Let's take a look at this angle C. And I'm just going to write over here that I know the cosine of angle C equals, well, cosine is adjacent over hypotenuse, so it equals x over a. And if I solve that for x, I get a times the cosine of angle C equals x. Now check this out. This x here is the same as this x over here. So let's make a substitution. So I get b squared minus 2 times b times a times the cosine of angle C plus a squared equals c squared. Now that right there is the law of cosines. We need to just write things in a different order. C squared equals, I'm going to put these two terms together, so a squared plus b squared minus 2 times a times b times the cosine of angle C. And there's where the law of cosines comes from. That one's kind of complex, but make sure you know it. I guarantee you it's going to be on your next test. Okay, that wraps up your notes on this unit. Check out some homework, get some practice on these. Especially make sure you practice, because there are some in here where you have those ambiguous cases with 2 solutions or even no solutions. Practice those. Make sure you understand those.